Hello everyone, my name is Gururaj and I am here to explain my OS assignment, which is the hybrid CPU scheduling using the FCFS and RR. Presentation explanation moving on. In that, I will explain about the introduction. In the introduction, what is the OS? OS stands for operating system, which gives to us process the instruction. In that, after I will explain about the CPU scheduling. In the CPU scheduling is a key function of the operating system that decides which process runs on the CPU and for how long. Since may process are waiting and only the CPU may be available, the OS must allocate CPU time efficiency, reduce waiting and running time, increase system performance. In that second, overview of existing scheduling algorithm, FCFS stand for the first come, first serve. Process are executed in order of arrive. Simple but long process, delay short times, convey effect. RR stands for round robin. Each process gets a fixed time quantum, good for responsiveness. Too slow quantum, context switching overhead. Too large behaves like FCFS. Objective of our assignment and the experiment setup. Combine two scheduling algorithm to create a hybrid scheduler. How it works using an example. Evaluate how your hybrid model improves performance. First hybrid scheduler using the FCFS plus RR. Implementation steps. Input, divide each process, burnt, execute FCFS. Why combine FCFS and RR? FCFS handles short queries very efficiency. RR is excellent for the time sharing systems and frames. Combined better response time plus reduce waiting time. How the hybrid algorithm works. Step 1, check the burst time. If burst time equals to quantum time schedule using the FCFS, such process finish quickly without the unnecessary context switches. Step 2, for longer process, use the round robin with the fixed quantum. Ensure fairness and responsiveness. Step 3, merge results into a final Gantt chart. This hybrid model avoids the FCFS convey effect, avoid RR overhead for a shorter takes, provides balanced performance. And here is our flowchart by the steps by step process. Example for the demonstration, consider process and burst time. Process up to 4 process, burst times are 4, 9, 5, 12. The seconds are in the milliseconds. Assume time quantum equals to 6 milliseconds. Classifications short in 6 milliseconds is FCFS-Q, P1, P3, long greater than 6 milliseconds, RRQ, P2 and P4. P1, P2, P3 and P4 stand for process. Execution flow, FCFS-Q executes first, P1 is 4 milliseconds, P3 is 5 milliseconds. RRQ executes next. P2 runs 6 milliseconds, remaining 3 milliseconds. P4 runs 6 milliseconds, remaining 6 milliseconds. Performance evaluation, advantages of a hybrid model, better responsive time for the shortest process, less waiting time compared of a pure FCFS, fair P CPUC disturbance compared to RR, efficient for mix of an short and long process. And after that, here is our Java code which is used to hybrid scheduler using the FCFS and the RR. The code is going through, and finally here is our Gantt chart using the output. In the Gantt chart, first we input the data. Number of a processor is 4, processor 1, 2, 3, 4, arrival time 0, 2, 4, 6, burst 10, 5, 8, 6. In the final output, using the Gantt chart, P1 0 to 5, P2 5 to 8, P3 8 to 10, Swan goes on. Process waiting time and TAT stands for total arrival time. And the process waiting time and the total arrival time is given this 9, 16, 11, 12, 19, 27, 23, and 25. Average waiting time is 12.00. Average turnaround time is 23.50. Total context switches 8. After the moving on the observation, turnaround time balanced avoids long saturation like PCFS. Context switches strictly more than FCFS but less than pure RR with the small quantum. And finally, we moving on comparative evaluation table has this. After the comparison evaluation table, moving on the final of our conclusion, A design of a hybrid scheduler combining the FCFS and the RR, reducing a waiting and turnaround time, improves the response time, removes the disadvantages of each standard algorithm. This makes it suitable for real-time systems, time sharing, OS, generally purpose computing. Thank you for this opportunity. Thank you.